Hello students, see this one of the sums in geometry. Here the information given is we have triangle ABC. There is AD, angle bisector of angle BAC. This AD when extended intersects circle at point E. We have to prove AD square is equal to AD square plus, in the bracket it is BD into DC is equal to AB multiplied by AC. If you look at this particular problem, what is given? One important information is that AD is a bisector. So you should understand we have to apply angle bisector property of similarity. Next, they have not mentioned D is the center of the circle. So since D is not the center of the circle, AD cannot be a median. But there is one more possibility. There are two chords BC and AE intersecting internally at point D. Hence, there is a possibility we can apply the property of internal division of chords, or we can tell property of internal divisions of secants. So let us try how can we do this particular sum. There is a construction in this. Construction, we are supposed to join CE. We'll join CE. Okay. Now, can anyone think which two triangles will you select? For me, I think we can take triangle ABD and triangle AEC. Let's see, can we prove these two triangles similar? In triangle ABD and triangle AEC. If you observe this particular triangles, we have angle B here, which will become congruent with angle E. Can anyone tell? Guess. Angle ABD, if you see properly, angle ABD and angle AEC, they will be congruent because they are the angle inscribed in the same arc. Is it clear? Angle ABD and angle AEC are the angle inscribed in the same arc. So I'll write angle ABD congruent to angle AEC, that is angles inscribed in same arc. Next, angle BAD is congruent to angle EAC. Angle BAD is congruent to angle EAC. This is, I think they have mentioned here, angle bisector. Can you make it out? AD is an angle bisector. AD angle bisector given. Okay, with that we can prove triangle ABD similar to triangle AEC. Therefore, triangle ABD is similar to triangle AEC by angle test of similarity. If the triangles are congruent, we can get proportional sides. First two upon first two. So that gives me, therefore, AB upon AE is equal to BD second third upon second third EC is equal to AD upon AE, AD upon AC. This is proportional sides of similar triangles. Among this, we will get two ratios which we can multiply and we can get something of this particular to prove that. Anything there as such here? So if I take AB into AC, AB into AC, that will be equal to AE into AD. So I'll try to ignore this particular ratio. Let's cross multiply. So what I get is that AB into AC, AB into AC is equal to AE into AD. So some part of to prove that is there. Now AE can be written as, can you split AE? If I split AE, I'll get AE can be split up into AD into AD plus DE into AD. We are just splitting this particular part AE. That's because A dash D dash E. Okay. Now let's open the bracket. If I open this bracket, AD into AD, I'll get AD square plus this I cannot multiply, but at least I can write in a bracket AD multiplied by DE, AD into DE. So finally I get AB into AC. AB into AC is equal to AD square plus AD into DE. So this was in statement number 1. We reached up to this particular part. Point number 2. I had even told you that there are two chords which are intersecting internally. If I use the property of internal division of secants, can I get something? I'll get AB into DE. AD into DE is equal to BC into DC. Can I put that property somewhere here? BD into DC. So what should I get? It is BD into DC. BD into DC is equal to AD into DE. This I get from property of internal division of chords. Now let's see, can we substitute something? If you see statement number 2, we have value AD into D, and this AD into D is even present here in statement number 1. So what we can do is that we can replace AD into DE by BD into DC. So what do I get? Let's see now. Point number 3. So I am substituting the value of AD into DE in my statement number 1. So that gives me AB multiplied by AC is equal to AD square plus. So instead of writing this, we are supposed to put this value of AD into D. What is that? BD multiplied by DC. This gives me the to prove that what is required. Just see that AD square plus BD into CD is equal to AB into AC. Thank you.